Graphs of horizontal and vertical lines. First, I want to start off by talking about Mr. Slope Guy right here. Mr. Slope Guy is just a picture you can draw to help you remember how slopes go. If you have a positive slope, it is an increasing linear function, so it makes up this eye and eyebrow for Mr. Slope Guy. If you have a negative slope, you have a decreasing linear function. So once again, eye, eyebrow. If you have a vertical line, you will have an undefined slope. So that U right there means undefined. And then if you have a horizontal line like this, those dimples represent that there is a zero slope. So undefined slope, zero slope. Positive is an increasing function, negative is a decreasing function. So if it helps, great. If not, no need to use it. The main thing that I want you to get from this is that a horizontal line has zero slope. The way that you would write an equation for a horizontal line is y equals a number. We talked about this previously. The reason why it would be y equals a number is if we have something that looks like this in our coordinate plane. So let's say it goes up 2 units. It goes left and right forever, but something that's consistent is that the y value is always 2. We use those consistencies to write the equation. So y will always equal 2. That's why the equation for this line is y equals 2. Bringing us back to slope as well, we talked about how slope is rise over run in the past. Does this have a rise? No, it does not. It has zero rise. Does it have a run? Yes, it does. 0 divided by any number is just 0, making this a zero slope. If we take a look at a vertical line, so I'll switch colors here for this one. If I have a vertical line, we let that be equation x equals a number. And this time we're going to have an undefined slope. So let's talk about that. Let's say at -3, I have a vertical line like this. Now with this vertical line, it rises forever. Okay, it goes up and down forever. But what's consistent, what never ever changes, is the fact that x will always equal -3. We use that consistency to write the equation. And bringing us back to slope, m equals rise. Yes, this absolutely has a rise. But run, does it ever move horizontally? No, it does not. So if we're talking about rise over run, we have 0 in the denominator, and you cannot do that. That's what makes it an undefined slope. For our first example, what we're going to do is we are going to list 3 coordinates from the line. So here's our line right here. It's kind of hard to see, but we have a horizontal line. If I want to list 3 coordinates, that could be any solution or any point on this line. So I'm just going to pick at random. I'll go here, here, and here, because why not? I'm going to write my list in a table. You could also just do individual coordinates if you want. Let's take a look though. I happened to pick, this has a x value of -2 and a y value of 1, 2, 3, 4, 5, and 6. This coordinate right here, I went right 2 units, and once again up 6, so 2, 6. And then this coordinate right here, I went right 1, 2, 3, 4, 5 units, and then once again up 6. So you can see in this table, yes, our x value is changing, but our y value is consistent. This is making a horizontal line, and a horizontal line has a slope of 0. If I were to write an equation, the equation would be y equals a number. So in this case, that number, what y always is equaling, is 6, which we saw. As always, you're responsible for the on your own. I do want to project the answer for this real quick since it is different. So I'm just going to pull up my key real quick. If you were to do this on your own, you could pick any points that you wanted. Now this time, this is a vertical line. A vertical line has an undefined slope. And that would give me x equals -3 for the equation because it crosses the x-axis at -3, and x is always -3. It rises, but it never changes horizontally. Okay, what we're going to do next is we are going to take some time and look at actually graphing them ourselves. So that brings me to this paper right here. We're going to graph the line and then list 3 coordinates from that line. It could be any 3. This is sort of like practicing writing solutions. Solutions are any coordinates on any given line. Non-solutions are any points that are not on it. So the first thing that I see is I have the equation x equals -3. So x equals -3 is an actual equation. It's not just one point. So you don't just go to my x-axis, put a point at -3 and stop there. Okay, x is always -3. So that means that we are creating a vertical line. It will have a rise, but it will not have a run. And if you have a rise but no run, remember, that means that the slope is undefined. So this is what we want to put for slope whenever we have a vertical line, is that phrase undefined. For example 3, this time we are going to graph a y equals a number. So y equals 0. Once again, this is an equation. We're drawing a line here, not just one point, a line. So it's saying y is always equal to 0. Well, here's my y-axis right here. If y is always 0, it means it will never rise. So for this one, I have now created a horizontal line. My slope, remember, rise over run. There's no rise for this one. So we would say this has a 0 slope. As always, you are responsible for your on your own. I just want to show you the projected answers real quick. Y equals 9 is going to be a horizontal line since y is always 9. And then my slope is 0 for that one. X equals 0 is a vertical line. For vertical lines, your slope is undefined. Something I forgot to do, my bad, is list 3 coordinates. So I just want to show you if I would have gone back and listed those 3 coordinates. I could have picked any coordinates at all. I happened to pick -3, -1, which is right here, -3, 0, and -3, 1. I could have also picked something like -3, 10 if I really wanted to. This is just to show you that consistency. That's why I asked it. So you can see for the vertical line, x was always the same. For the horizontal line, y was always the same.